Hello everybody, welcome to my presentation on cryptocurrencies. I'm Moeezy Sr. and here's Moeezy Jr.
Hello.
Alright, so I'm going to be explaining to everyone and to my son about cryptocurrencies. I've already explained to him, but he has more questions, and this one will go a little bit more into detail, and you can actually follow on screen. I made a PowerPoint. And in the future, I'll also make another video that will actually be even better. And I'll make more videos on the different actual cryptocurrencies. So, cryptocurrencies. A cryptocurrency is a digital asset designed to work as a medium of exchange that uses strong cryptography to secure financial transactions.
Wait, so what's cryptography?
So, cryptography is a way of like hiding information. So, say, and it's because everything on the computer is code, and it's so if someone has the code to your coins, they can actually copy your coins and spend them, or so everything has to be encrypted. So say like this is the physical form of encryption. Say I wrote you a letter on paper, and I don't want nobody else to see this, but I have to send it to you. Or even if I didn't have to send it to you, so I break the letter up into pieces, and you're the only person that know how to put it back together. So you would be the person decrypted. I encrypted the letter, you would be the person who decrypted. You know how to. So say it was a really, really good encryption. Say I had the letter, I cut it up into 1,000 pieces, and I put maybe a third of the pieces in one envelope, a third of the pieces in another envelope, a third of the pieces in a third envelope, and I sent them all from different places at different times. So whoever would try to read that letter would have to get all the pieces from different spots, and then after they got them, they still would have to put them back together. So that's what they're doing with encryption, but they're doing it with computers. So they're making sure that there's pretty much it's impossible for someone to get that information. So you got a better understanding?
Mm-hmm.
Okay, and I will go. And encrypted means it's using cryptography. Encrypted and cryptography are the same thing. So wallets are encrypted, and funds can be withdrawn with a private key, and funds can be sent to a wallet with a public key.
What's a private key and a public key?
Okay, so your private key is never give out your private key. That's why it's private. It's between you and whoever you would want to, like, that's to take money out of the wallet to send people money. Your public key you can give to the public. So if you could you could put the public key, which, hey, we might put our public key down. So if you want to help us, you can send us some money. But your public key you can give to the public, and that's how people send you money. So private key, keep it private. Public key, you send easily. So, and your wallet is pretty much like a bank. Okay, so here's the history of cryptocurrencies. Cryptocurrency started in 2009 when Satoshi Nakamoto released Bitcoin.
Wait, who is Satoshi Nakamoto?
Okay, well, he was a programmer, and first, Satoshi Nakamoto is a pseudonym, which means a fake name, like a alias. Okay, and he was the programmer. He was the one who created Bitcoin, which you could look at the Bitcoin. He's the one who made the white paper. Do I have that white paper over there?
I think you do.
Okay, go check and grab the white paper. But he's the one who made the white paper about Bitcoin, explaining Bitcoin. So we're gonna see that white paper, and I suggest everyone read the white paper. Whatever you can understand, you just read. Okay, but and it's online too. I mean I should have put a line to it, but here's the white paper. Bitcoin, a peer-to-peer electronic cash system, and he explains it, and he came out with his white paper, and it explains Bitcoin, and so he was a computer, and no one knows who he is. People had even said he was dead, but now I guess people are not saying it as much, but in May of 2010, Bitcoin was less than 1 cent. Okay, so I remember the first bit. This how Bitcoin became got its first value. They showed 10,000 Bitcoin. So let's check. We're gonna check on that. 10,000 Bitcoin for a pizza. Okay, let's see. We're gonna look that up really quick. For a pizza. 10,000 Bitcoin. Okay, he has no regrets. The $80 million pizza order. Okay, so that's how Bitcoin's celebrating. May 22, 2018 marks an 8-year anniversary of the first Bitcoin transaction in which a Florida man paid for 2 pizzas with the cryptocurrency. The day has become part of folklore. Not because of the transaction, but more the price. The man in question paid 10,000 Bitcoins, which today is worth over 80 million for 2 pizzas. So the first transaction, someone paid 10,000 Bitcoin for 2 pizzas, and this was in 2019. So do we have a calculator on here? Because if we do got a calculator, now we can see what it's worth now. Okay, calculator. All right, so 10,000 times, what's the Bitcoin price? Hold on, let's check. 57,801. Ooh, it went down fast. Okay, 57,781. We gonna just do that. It's changed so much. 57,000. 57,000. How much was that, Moeezy?
781.
781. Okay. So now that pizza is worth, those 2 pieces are worth $577 million. Wow. $577 million. So now those pieces are worth $577 million. So let's get back to the PowerPoint. So it started less than 1 cent, and someone paid. It started as 10,000 Bitcoin for 2 pizzas. Now the first altcoin was created in the early 2011 because people wanted to start trying to say, okay, we got Bitcoin, let's try to make some new stuff.
What's an altcoin?
Altcoin is pretty much any coin that's not Bitcoin. That's what they named it. Even though, I mean, Ethereum's starting to get so much value, people don't feel comfortable. I don't feel comfortable calling Ethereum an altcoin no more. But I mean, technically it is. Okay, now by February 2011, less than 2 years, Bitcoin reaches $1. Now we saw Bitcoin is worth around 60,000. It had went over. It goes up and down a little bit, but it's been consistently over $50,000 lately. Okay, so economics of the reason why Satoshi Nakamoto created Bitcoin was to create a peer-to-peer trading system without the need of a third party.
What's a peer-to-peer trading system?
Peer-to-peer, like me to you, or me to anybody, or you to another person, an individual to another individual, without the need of like a bank. Because usually if I have to send you money, it's like going through from my bank account going into your bank account. So we have the banks holding our money and all that stuff. So if you have a wallet, if you have a crypto wallet, I got a crypto wallet, and I got your public key, I can send you money. You got my public key, you can send me money. Anybody got your public key, they can send you money. So newer cryptocurrencies like Ethereum allow you to cut out the third party of borrowing, lending money, data storage, and many more things. Because you got things like you can actually get paid for like storing data, and then they actually have, you can borrow crypto. You can actually lend crypto. They have pools like liquidity pools where you provide you provide your crypto that you have, and then you'll get a percentage on just holding that crypto. Okay, now cryptocurrencies are doing everything a bank can do for you without the central authority that can print money at will. Because as you know, I've taught you, banks print money a lot, and most money that is printed most money isn't even printed. It's in a form of bank credits. And do you know how bank credits happen? When do bank credits happen?
No.
You got any guess? When the banks just add money to their balance sheet. When do they do that?
And when they're lending out money?
Yep, exactly. So when people get loans, that's when banks get to add bank credit. So that's even more than what gets printed out. And that's where most money's created, through bank credits. But my sons will be doing a video on the stock market, and I think they have something about that, about how much the percentage of money that's bank credits. So a lot of cryptocurrencies like Bitcoin have their max supply capped at a certain number. Okay, so for instance, Bitcoin max supply is 21 million. They've already printed out, and we can check that really quick. Let's go over to, you see that? It's 21 million. Let's look at that. Let's see. See? Max supply, 21 million. The circulating supply is 18,698,350 Bitcoins. So they got 2 million and something to go, and there will not be no more Bitcoin printed out or be able to be mined. So the price is going to go up even more, because you understand why when you print money the value goes down.
Mm-hmm.
Okay, so all right. So let's go back. Okay. And not even 1% of the U.S. money supply is actual physical dollars. Most of it is digital. Most of everything is digital. So people act like they can't understand what cryptocurrencies are when you tell them it's digital money. Like, what is it? Or it doesn't have value. And it's like, okay, then most of the money you spend doesn't have value. And your money can just get the supply can get doubled within 2 years it will be doubled. Okay, how cryptocurrencies work. Let's get down to the nitty gritty. Transactions are verified by a network of computers, and those are the miners, through cryptography and recorded on a public ledger called a blockchain. Each block is a group of transactions that, once verified, they're immutable, which means they can't be changed. So that's what makes it to where people can't just try to change things. Once I send you some money, it can't be reversed. You can't say, "Oh, he didn't send it to me" or nothing. It's on the blockchain. So I can verify that. You can verify that, and I'm going to show you why. We're going to do it. We're going to go on Block Explorer, and you can actually see. And miners use their computing power to maintain the accuracy and the security of the ledger. So all these computers are actually verifying all these transactions, and they're time stamped. So when all these transactions are time stamped, you can't go back and change it. You can't this. So but as you this is a thing. This will help people because we're gonna go to Block Explorer. So the blockchain is actually it's a public ledger. So this is what it means. Public. You can actually look at it. So let's go to Block Explorer. Right? Okay. Boom. So we can actually check. First of all, let's take that off. Okay. Now market cap over $1 trillion. This is Bitcoin's blockchain. Circulating supply, which we say, and this is their hash rate. Okay, this is how much computing power is being consumed and used. Okay, now here's the different blocks. Okay, different blocks and so that the number sign 6, the number 681716, that means it's the 681,716th block of Bitcoin that's been produced. So that's how many. Now we actually can click on that block. Okay, let's just click on it, and now we can see. Now, okay, now look at this block right here, and it'll tell you everything. So transactions per second. So Bitcoin does 3 transactions per second, and Bitcoin, to tell you the truth, it's a slow blockchain, and we're gonna get into that. But look at the hash rate. That's a lot of power. Total transactions 638 million. Pending transactions 855. Okay. So now you can actually look. You actually can go into transactions and see. This one happened 14 minutes ago. Oh, so let's go on the block. Okay, let's go on the actual block. Okay, now look. Here is that block, and blocks get created in Bitcoin every 10 minutes. So this block has 22,292 transactions. And guess what? You can see Binance Pool. This is why Binance Pool is one of the biggest pools. They're the ones who created the block, because different people get to create you get to create the block, and then other people get to verify it. The winner, whoever has the most electric power or had computing power, like the more computing power you got. This is in Bitcoin's blockchain. The more computing power you got, the higher chance you got of being the one that writes the transactions. That means making the block, and then other computers verify the block, and then they get rewards. Here's a block reward right here: 7 Bitcoins. How much is 7 Bitcoins? 7.111. We'll just do 7.112. All right. How much did we say? 7.112. All right. Times 57,781 equals. So they just got 400,000. So the miners just got, just from that block, $410,938.
Is this rewarded to one miner or all the miners?
No, that's the total block reward for. So the person who wrote it gonna get the most, and then the verifier, and it goes by computing power. How much computing power you put towards it? Whoever put the most gets the most rewards and stuff. So that's why, like Bitcoin, it's more centralized, meaning it's more people that got most of the power, most of the computing power. So, and I'm gonna get into that why that's the first generation blockchain. Okay, so but Binance Pool got the biggest reward pretty much. And a pool is a group of miners that get together and they pool their computing power. So they got their 400,000, and that tells you how difficult it was and the size, and it shows you it just been confirmed. This block is recent. You see, 11:49, right? Date and time. It's been about 20 minutes ago. Okay, so you actually can see. Let's go. This transaction was from these people to these people. They even tell you the fee, I think. And the fee was $299. Now this one, fee was $6 and they sent 31. Oh, it's a little hefty. So it's better to send more money, because you see they send 3,000 and the fee was 17. You see all this? All right. So all right, that's enough of that. But all right. So you see, and you see that this block happened, which tells you can see it. May the 3rd. Today's the 3rd, right?
Mm-hmm.
Okay. Boom. At 11:49. That was 30 minutes ago. And if we refresh, it probably had another confirmation. Oh no, not a confirmation. Bitcoin blockchain is a little slow, so you know. But let's get back to it. Alright, so you see how miners use their computing power, which they have all that hashing power, hash rates, because they use the hash. They pretty much, it's a math problem that they present, and the computers just guess, and the computers that have the more hash rate guess faster, and the one that gets the guess is the one that gets to write it. So the more hashing power, the more you can have people guessing, and then you'll get most of the reward. And that's how Bitcoin is produced. Okay, so this is how I was using a poker example. How the blockchain would be better for poker than you know, people, because I used to always wonder how people just throw money in on poker, and it's like, how they keeping track of who owes who what? People just, everybody just throwing money in. If you had the blockchain, it would be a lot easier to keep track. So every time the money would get exchanged from another player to from one player to another, or multiple players, there could be a recording of it. So then at the end, like, someone could be like, no, I put this much in, or I put that in, or you didn't put in. You would know if the blockchain just had it, and people wouldn't really even need to. You could just enter your amount, and it would stay on the blockchain, and no one could go back. No one could go back and be like, well, I didn't do this or I did that. So, all right. So we have first, second, and third generation blockchains because they've evolved to do things. And Bitcoin blockchain was very useful, and then they had ones like Ethereum come, and it's been very useful. And now they have ones, and they keep evolving. And we'll have a fourth generation blockchain. So, first generation blockchains are based on proof of work. And proof of work is pretty much showing you have something that's working to help to secure the blockchain. So, computing power is proof of work. Okay, so miners, they need to have a resource that they give, or it'll be easy for hackers to disturb the network. So if say to mine Bitcoin, you didn't have to have anything, then that means hackers, because what hackers can do to cloud the network, they can put a whole bunch of transactions in, because a network can only take so many transactions at a time. It's still, the computer can only take so much. So if a hacker, and that's what they do to just make it, to bring it down, they'll just run a whole bunch of transactions. So for that reason, you have to have people that can show that they actually are using computing power. So if you have something that people use, then there's something that it's just not free will to come in. Anybody can come in. So I explained in proof of work they offer computer power, which also helps verify the blockchain. Okay, so Bitcoin, Litecoin, Dogecoin use first generation blockchains. I mean, Litecoin, it was a fork off of Bitcoin, so it really was like, it was Bitcoin, and then it split up. Bitcoin split up, so it's a little bit different, but it's like Bitcoin. Dogecoin copied Bitcoin, and it was a joke, and so it was a meme, but it just, people start buying it, and if people start buying something, then it's worth money. All right, here's some problems with first generation blockchains. They are hard to upgrade.
Why are they hard to upgrade?
Because first of all, they didn't Satoshi Nakamoto, he didn't want a lot of people to be able to change it. He wanted Bitcoin because he wasn't planning on being involved in Bitcoin forever. So he wanted to make something that could stay what it was and didn't need him. So he wanted it to be a certain way, and then he could leave and it would stay the same. And Bitcoin, it's good. It's done its job. Bitcoin is what it is, and it's been the same thing that Satoshi created, and it's still here. But there's other cryptocurrencies that want to do more, that want to, people need other things. So it's almost impossible to add dApps. dApps are decentralized apps, which means like it's not like an app by one company or one group. It's a app ran by many. So and they also have governance problems. So that's part of the reason why it's hard to upgrade. Which means like if there's problems or if people need to vote on a change or something, like, hey, we want to change it. We want to make like Bitcoin has 10-minute a block every 10 minutes. If they want to go to 5 minutes, it's too hard because certain people agree, certain people disagree. That's how you get Litecoin anyway. Litecoin, they have blocks every, I think, 2.5 minutes, but that's why they fork off of Bitcoin. The people with Litecoin, they want smaller blocks, and they want them to come fast. They want them to be faster. So they, just to get that, they had to get off of Bitcoin. And there's a whole bunch of other things like Bitcoin Cash, and it's a lot of coins that are here that forked off of Bitcoin. Bitcoin SV. It's other things too. It's a lot of things, because every time you have a disagreement, it's like, okay, well, we can't agree. So the people that disagree, just, you gotta fork off to something else. So that's why. But they have other coins where they actually have governance. Like the people who own the coins, they vote. They all vote on different things, and then the vote decides what happens. So and another problem with the first generation, they use massive amounts of energy. Bitcoin uses about the same amount of energy as Argentina.
Dang, that's a lot.
That's the, yes. So that is, and they only work on one block at a time. So 10 minutes. So say I send you 10. If I send you some Bitcoin right now, you're gonna wait a little. You're gonna wait a few minutes, and then every block takes 10 minutes to be verified, and then they have to verify it again, like confirmation. So sometimes if I send you money right now, it might not go through for 30 minutes to where, and as with other cryptocurrencies, like with I know with Cardano, I could send money now. By the time you looked at your computer, it would be there, and the confirmations would come like within 5 minutes. Probably you could spend it. So and there's less security. There's less security.
Why do first generation blockchains have less security?
Because they're harder to upgrade. So if there's a problem, say people hack, because people have hacked into different blockchains or different things. Like when there's a problem, it's hard to upgrade, so it's less security. Say you find that there's a bug, or because most code has bugs. Now, how are people going to agree to change it? Like, but yeah, there's been things where people have they've stolen a lot of money. There's a thing called Mount Gox. I forgot how much they stole in Mount Gox, but we can look up Mount Gox. Mount Gox. Okay. This was how much was stolen? Amount valued over 450 million at a time. Well, at the time. So yeah, they stole. But they still have the same, they have some of the same problems. They have some of the same problems on second generation, but we'll get to that. And they work on one block at a time, so every 10 minutes you will be waiting. Alright, second generation blockchains. Okay. Second generation blockchains like Ethereum, they use proof of work also. But they also can use proof of stake, and you can add dApps to them. This decentralized apps. And proof of stake, miners have to stake coins to get rewards. Meaning, you actually have to have the coin, and you have to actually put it up, like put it into like a wallet to get rewards, and that's how they'll mine it. So that's who they decide they give the new coins to. And proof of stake, they have people verifying, putting up the transactions, but they have what they call stake pools. So there's only really one person, main computer from the stake pool that's writing the transactions, and then there's other stake pools verifying. So it takes a lot less power, and each stake pool can write a block, and they don't have to wait to write the blocks. So you can add smart contracts and dApps. So I'm gonna tell you what a smart contract is in a second, so you know. And dApps are like exchanges where you can go on and exchange different cryptocurrencies or dollars for crypto, Ethereum for Bitcoin, or ADA or Polkadot or whatever, and different things. And dApps where you can have it where you can like lend. They have apps or dApps where you can lend money, borrow money, games. Well, I said games. So and they have a limited second generation blockchains. They still have a limited scalability. Like Ethereum, they have a limited scale. Like their gas fees are very high, and so as more people use Ethereum, the gas fees go really high, and that's a big problem. So we can go back to Block Explorer, and we'll check out Ethereum. All right, we'll go to this blockchain Explorer. Now let's check. Boom. Look at those. Look how quick they coming up. Okay, so I guess they blocks come up faster, more than. So let's see. Let's see these transactions. Bow. Damn, we only sent $3 and the fee was $7. Hold up, let's go. That can't be right. Let's go back. Try this one. Okay, yep, that's probably right. $7. So transaction fee is about $7. They sent $7.53. So that's better than before. Another 3,000. Dang! Oh, just swap 21 for nothing. Oh, that's why them ones be nothing. They just swapped it on 1 inch. They did a swap. That's a exchange. So $21 just to swap. Let's see what else they got on here. Okay, hold up. Let's go for some more. A couple more. Uniswap. Uh-oh. Let's see what Uniswap. You know them fees be so high. $40. 16. That ain't bad though. But these people spending 16,000. But that same $40, if you send like a small amount, you still get that same big old price. So it's good for people that's sending that. We'll look at last one, transfer. I guess those was okay. So we're gonna go back. So all right, smart contracts. Smart contracts are contracts that automatically execute if conditions are met.
What do they mean by contracts?
Like it's a agreement. So let's say they say if a certain thing happens, so you can make it to where if someone delivered something to your house, you could make the smart contract automatically pay them. And the smart contract would hold your funds. And if they didn't come to your house, then the smart contract would not execute. Parties can remain anonymous without the need to trust a third party, which means you don't have to know me and I don't have to know you, but we can do business. And I don't need to trust you, and I don't need to trust you either. So it's trustless. Just imagine how the crime rate would go down if people didn't have to meet each other and be guaranteed product or cash. That would make it a lot easier. People wouldn't even have to, we wouldn't have to be face to face. Maybe I could have a lockbox or something and put the stuff in the lockbox. And if you, when you come there and if you put money in there or something, the lockbox opens. Or the smart contract can hold the money and send it to your account. Smart contracts are stored on the blockchain in open source code so everyone can analyze them. So anybody can look at the smart contract and see, oh, okay, this is what it is. People that know how to read code and all that can know exactly what it does so they can see if there's any problems or anything. Okay, the problems with second generation blockchains. They have governance problems also, like Ethereum. That's why they split into Ethereum Classic, because there was something called DAO, the DAO hack, where they hacked into one of Ethereum's smart contracts, and they figured out how to take money out. And when Ethereum found out, the people at Ethereum, they decided some people wanted to just undo the fix the contract and then take the money out, and another group, they wanted to do a little bit less, so they disagreed, and then they had Ethereum Classic. So they don't have a real they don't have it where you can really like vote on a lot of things. So, and they have scalability issues like and network congestion, because the fees get really high, really high. Like as I showed you, like you can't send $20 to an Ethereum wallet and then send it back out, because by that time it'll take all your money. And so it's really not for the average person, because you see most people sending a lot of money, and if you send a small amount, it's going to take your money. And the miners, they tend to be greedy. Like the miners, they want to keep transaction fees high and stuff because they want to make more money. And Ethereum's getting slower. The fees are getting lower, and the miners, they're already complaining. And they evolve slowly. Where we at? Because it's also kind of hard to upgrade them too, because it's just pretty much, it's hard for people to agree on the changes. And they work on one block at a time, even though they are faster. Third generation blockchains. Proof of work is usually replaced by proof of stake. And I've explained proof of stake, where people actually have to have a stake. So they actually have to own the coins. So ETH 2.0, they have proof of stake, but say you wanted to stake your coins now, you actually have to keep your coins in ETH 2.0. So if it goes down, you'll be stuck and you can't take them out. And there's other proof of stakes where you have to keep your coins in for a certain time to get rewards. But with Cardano, they have things called epochs or whatever, and that's like a period of like 5 days. So every 5 days they give out rewards, and you don't have to keep your money in. Like if you take your money out before the epoch is over, you might not get the rewards, but you can put your money in and out as it pleases, as you please. Well, yeah, so you don't have to wait. You can put your money in and out as you please, man. Now they're more scalable and interoperable with other blockchains. Right now, you have to use exchange to trade between blockchains. Like if you want Ethereum for Bitcoin and all that, you have to go on the Coinbase and all that. But they're making things where you can trade. You'll be able to trade coins without going on an exchange. And they finalize transactions almost immediately. So these transactions, because if you can't have an ATM machine with cryptocurrency, if it weights like Bitcoin, they have the Bitcoin ATM machines, but you really can't get it because when you do a transaction, it's going to take 30 minutes. So really, it's the coins that will be on that will replace ATMs have to be as quick as an ATM, so have to immediately. So and they actually have governance and are constantly evolving. So they have so if you have coins on third generation blockchains, say they have things you can actually vote on different things that they want to develop and different things, or you can vote on the rewards or mining rewards and stuff like that. So that's good. Okay, so Cardano and Polkadot are examples of third generation blockchains, and they work on multiple blocks at a time. And you can run a node and use a lot less power. You can run a node using a Raspberry Pi 4.
What's a node?
A node is a computer where you verify transactions. Computer is a node, pretty much. So I was just showing you, here's the berry pool. And this one is a pool, stake pool, that writes and verifies transactions with the Raspberry Pi, which we have a Raspberry Pi for. And they actually make a rate of return is 3.6% just using and their live stake is 5.51 million ADA. So that's pretty good, and you get and it's just a 1.5 fee. So with the Raspberry Pi, and I'll be looking into that. I might start me a stake pool with my Raspberry Pi, but I gotta see how much more. I think my internet sometimes isn't the greatest. But yep, there's that stake pool, Raspberry Pi, and this guy right here, he does space buds too. That's NFTs. If y'all know about non-fungible tokens, like art and stuff like that, he got space buds. So check that out. But pretty cool. So why I like proof of stake over proof of work. Sorry about my slide. I was missing. Okay. Miners have a stake in the project to deter them from coming and going. So you know how Bitcoin goes up and down and drops? It's because a lot of their miners, when they get a lot of mining, they could just sell when the price goes up. They don't even have a lot of coins actually in stake of their coins. So if you actually had to have a lot of your coins at stake, when you made the price drop, you would make the price of the coins you already had at stake drop. And then if you have good governance, if people are selling, you can make rules for the people that sell a lot for them to get less rewards, and the people that hold get more rewards. So that deters people from, hey, Bitcoin just went to 70,000. Let's sell. So that makes them proof of stake less volatile because users have billions staked in the coins. And usually your stake gives you the opportunity to make decisions and governance. See, so with POW, the miners don't have incentive to stay. And it causes the volatility because the miners dump the coins for profit. And with proof of work, people have to buy expensive equipment to mine, like ASIC units, and those ASIC units are computers that are designed pretty much for
mining.
Yeah. So yeah, and those cost a lot. They're up more and more, and they use a lot of energy. But POS, they don't use that much energy, and proof of stake, they're also more decentralized because they have they can have a lot more stake pools, and they have different people writing the transactions, making the blocks. So, for instance, this how Bitcoin is a little more centralized because most of the mining power is in China, and where I could show you. So you can look, and this recently, as of a few weeks ago, the mining hash rate dropped because China had blackouts. So if one day China decided to, if they couldn't make everybody dump their Bitcoin or stop, get off the Bitcoin network, then it'll be a lot of Bitcoin. They'll lose a lot of mining power. So it would be hard for transactions to go through. But no, that's somewhere they say where like more than just like 2 provinces have most of the Bitcoin hash rate. But yeah, that was just a little story to show you how. All right, now why should I switch to cryptocurrency? Or why should you switch to cryptocurrency? Because it's the future of money. It has a market cap of over 1.7 trillion and will continue to grow. Well, matter of fact, it might be over that right now. Let's check. Market cap is 2.2, almost 2.3 trillion now. And Bitcoin just went up to 58, while Ethereum is over 3,000, and Ethereum's market cap almost is 400 million. All right. So, and many people predict that Bitcoin could reach 250,000 in 2021 and eventually go past 1 million for a single Bitcoin. Yep. The value of the dollar is constantly going down, and they keep having to print it to pay for the debt that they've already accumulated. It is best cryptocurrency. It is the best store of value next to gold, but it has more usefulness and a bigger upside. Because gold, people act like it's more useful, but I mean it's useful for wearing, and I mean you can't do everything you can with Bitcoin. I mean because back in the day, gold would have been when people did hand to hand, but now most people do electronic transactions. So if I got a whole bunch of gold, a lot of people some people ain't gonna like. There's little things I can't do with it, especially physical gold. And then if I have physical gold, I gotta pay for people to hold my gold. Like real gold, people actually pay you to like, oh, I'm gonna have this vault and not have it in the vault. So you just gotta pay for it. When you can have Bitcoin and the value goes up, you could do more things with it, and other cryptocurrencies where you could do everything a bank can do plus more. Plus, like your video games, this could be on blockchain. You can send money anywhere in the world without a centralized authority. So we've been doing that. So pretty much that's cryptocurrency. You understand? What don't you understand? Is there any questions you have?
No.
Well, all right. I know it's been a little long, but thank you for those who watched any part of it, and thank you very much for all the people who watched the whole thing, and I hope this was very helpful.
Goodbye.
Goodbye.